This conference will now be recorded.
Usha, in last session, can you hear me?
Yeah, I'm able to hear you, Rekha.
Okay, in last session, we were looking into a topic called, which topic we were saying?
Star schema
And the snowflake schema. So you're clear about it? Do you have any queries to discuss on those topics?
No queries. Can you repeat for me that again?
Star schema is centrally located fact table surrounded by one or more than one dimension table. It is the simplest form of the schemas. And if you see, the dimension table in the star schema is denormalized in nature. That is, it will allow data redundancy. And the dimension table will have primary key in the attributes, and in case of fact table you will have foreign keys followed by the facts. This is how there is a primary key and foreign key relationship between the facts and dimension tables. Since this allows data redundancy as it is following denormalized dimension structure, we will have storage issue because we used to maintain lot of data redundant values. Okay. Similarly, in case of snowflake schema, it is very similar to star schema, but the dimension tables whichever used are normalized in structure. In the sense, the process of eliminating data redundancy is called normalization in RDBMS, and that redundant values to avoid, we will just split the table into multiple parts so that the redundancy can be eliminated and data can be maintained in a most probably the unique formats. So what happens here when you are trying to in the process of reducing the duplicate, when you are splitting the table into multiple parts, you will have n number of dimension tables, and so if there are more dimension tables and they are interlinked with each other and it is connected with the fact table, if you are trying to pull the data for analyzing the data, the query performance will be low. Why? Because more number of tables will always degrade the performance as your joins are more and the query complexity will be more. Can you follow?
Yeah, got it.
So any project, if you take in data warehouse, it should be following either star schema or this snowflake schema. If anyone asks you which schema type your project used, you can directly say that it's a star schema because it is the simplest form of schema. It is having a denormalized structure, though it has a data redundancy and it has a storage issue. We have mechanism to eliminate data redundancy by using our ETL tool before loading the data. So we are handling the data redundancy in the loading level itself, so we will not have issue on the database side. We'll try to anyway ignore the data redundancy, not via the schema, but via the ETL tool through which we will load the data. Clear?
Yeah, got it, Rekha.
Shall I move on to other topic?
Yeah, sure.
The next topic is somewhat very important and critical in case of data warehouse. Slowly changing dimension. Okay, slowly changing dimension. So SCD in a short form. There are different types of slowly changing dimensions used in data warehouse. That is, if suppose your business requirement is to maintain the historical data, wherein if they want to retrieve some 3 years of data or 5 years of data, yes, you do maintain everything in the database. You can pull it and provide the data to them for analysis. So this sort of maintaining historical data based on the business requirement will sometimes vary based on the business requirement. They will tell, see guys, I don't want to have a history of data. Rather, I just want to show the latest information. So it means you are not going to maintain a history wherein you are going to show only the latest detail. So based on the requirement, how you wanted to maintain a data, this SCD type will vary. So there are different types of SCD, SCD type 1, type 2 and type 3. These are very important decisions that we will take based on the business requirement. How the data needs to be stored depends on this type.
This conference will now be recorded.
Thank you. We are in SCD type. So SCD is a process to judge or to confirm how we are going to maintain a data. Okay, so the very first type of SCD is SCD type 1, slowly changing dimension type 1. So here in real time, how we'll receive a data is every day we used to receive data from the source system. Okay, so assume you are new to the project. Usha, can you hear me?
Like I am able to. Yeah.
Yeah. Okay, so in real time, suppose you are entering into a project and that project is a new development project. Once your all code development gets completed and your code testing process will start, even the testing, if it's completed and everything seems to be a business requirement and user acceptance testing, everything is signed off. So now we need to move the code from our development environment to the production environment. Okay, we will have different environments in your project, like development environment, testing environment, and then the production environment. When you are moving the code into the production environment, after moving it, you need to execute those jobs or those program or project, whatever you have done, right? That needs to be executed on daily basis. So when your project will be triggered in production environment when your source system sends the data, and after receiving the data, you need to trigger all those jobs. So there will be an agreement, or there will be an understanding based on the requirement. The source team who will provide us the data will inform us that, okay, on daily basis at this time I will be sharing my source data. Either it can be in a form of a file or it can be in the form of a database tables. So after that time, we should pull those data and populate in our process to the target system. Clear. So now this process, when you are implementing in production for the day very first time when you are loading, right? Assume this is a banking project, or it can be a retail project, whatever it is. So what they will do is, so far whatever data they have, maybe a 4 years data or 5 years data or a year of data, they will extract and they will share those data to you. So for the very first day when your project is going live, the data what you are trying to load will have huge volume in general, and that huge volume data for the very first time whatever they are giving, right, that data is called full load data. FULL, full load data. Why? Because whatever data they hold so far, everything they will share it to us, we need to receive that data and have to process that data. So that is called full load. So this full load will happen in the name of day zero. Day zero is the very first day when you are trying to trigger your job by using the data volume whatever available from the source system. So day zero data is always a full load. From the next day, today my load happened, I received the file, I have executed, my jobs ran successfully, my project go live was success, no issues at all. The next day, when we are expecting data from the source system, they won't be sending again a whole set of data. Instead, on that particular day, whatever transaction happened, right, a single day data, they will be providing us a single day data, and that data will be an incremental load. Already a load happened. On top of it, we are going to load it, which is called incremental load, or the other name for it is a delta load. Can you follow?
Yeah.
And let me repeat it. So the very first time when the source system is providing a data, that data will be the day zero load, and that is called a full load, where the volume will be high. This project might be already 3 years of past 4 years of data, 5 years of data they wanted to capture, and on top of it, every day they are going to send us a file. So whatever data they share, the volume will be high. For the day zero run, the volume will be high, which is called full load. It will take more time because you will have complete set of years of data, or the backup, whatever they wanted to hold, all data will be there. So when day one we are trying to load the data, every record is a new record, right? When everything is a new record, we will just go ahead and insert the data into the target system. If suppose they are sending some 5 million records, and 5 million record, you go ahead and insert it into your target data warehouse system. Tomorrow, they won't be sending again 5 million plus record. Instead, till yesterday already load happened. So today, whatever transactions happen from their end, they will extract those at the end of a day, and they will share the data to us. So now, today's volume, let's assume it's just 80,000 records, or 1 lakh record, or some cases just 10,000 record. Okay. So now what we will be doing is, we will cross compare this 10,000 record with that yesterday's loaded data, just to cross check whether these record already exist in the yesterday's load, or it is a new record. Why we are cross checking whether it is an existing record or a new record? Because we need to understand, if it is existing record, there are two possibilities. One, it can be a complete copy of a record which you can ignore it. Two, the record exists yesterday, but it has got some changes on the value. Yesterday there was a person who was there in India, and today is there in US. So there is a change in the location value, but this particular customer value already exists in a database. So the changed record, we need to compare this, whether this customer exists or not in the previous load and with the today's load. We will get to know that no, this is a new record. Yes, it is an old record. You need to cross check on the value changes. So once you get to know that there is a change in the location field, you go ahead and insert another record and have to mark the value as an updated value. So whether to maintain a history or to maintain a current data, we will have to decide based on the business requirement, and that will be decided by your business analyst, data modeler, your project manager, technical project manager. All those senior persons will consider into the project requirement and fix this SCD type. Now we are in SCD 1. So I'll see the data here. I have a day 0 load. I've just taken a sample of one record. There is an employee detail, employee 001001. His name is John. His department is 20. His location is India. And this record we received from the source system. We extract it. We do some transformation on it, and then we will load it into the target. Time being, I'm just pulling and pushing the data here. So I just kept the same data sample and data warehouse table. Whatever record we have received, just loaded into the target. In the next day, I'm receiving an incremental file. In that file, I have the same employee record, but his location changed to US. Okay. So now in my data warehouse system, already I have 1001 John 20 India. I'll cross check this today's data with yesterday's data, and I'll get to know that yes, there is this record already exists, but it has got the change in the location field. Now see in the target 1001 John 20, location is US. Now which is the latest detail that exists in data warehouse table? That is, if I query select star from EMP, where EMP ID equal to 1001, you'll have one single record, and that is this particular record. So what you can see now, this person exists in location US, but the record where it stated that he was in India, this record is not there. It is just displaying the latest data. You are not maintaining history here. Instead, you are trying to update directly on a data, so it will always have the latest detail. It will not have history of data. SCD type 1 is something where we will have only the current details and no history of data.
Okay.
Got it? So this SCD type 1 is just if there is a change in the source, yes, you are going to change in the target on top of the existing data, so that your existing data value will get overwritten. You will not maintain history. This is type 1. We move on to the next type, SCD type 2. So type 2 SCD is to store history of data. So if a particular record is repeated in a month for 5 times, so after the latest detail received, when you query that particular table, it will display 5 different records having complete history of data. Previous, current record, everything. Whatever you have, everything will be an insert. There is no update concept. So you should have the history of those records. For example, in a day 0 is a full load, I said, right? Yeah, there's an employee, his name, his salary, his office, and he will be effectively working in this office from this particular date. So this details we receive. If you want to maintain a history of data in the target table, you need to additionally have few of the columns to identify whether it is a new record or whether it is an existing record, and when this record got updated, when we received these records, these sort of few informations will be added from our end to the target table. So see the sample here. I have employee ID, employee name, salary, office. he is effectively working on this date in this office with this salary. So from date is I've taken from date as this date, and to date I don't know till how long he will be working in this office in this position. So to date a system generated end date, I'm just taking it some end date 2999. Okay, we are just in 2022. And when the moment when you insert a new record, let's identify that record with some flag field, and one of the flag field is current flag Y. So whenever you see Y in this particular column, all those Y records are newly inserted record. An identification sign for a business logic to maintain is to identify or to differentiate history record and a new record. We hold some flag columns Y or N or 0 or 1, whatever value you can have, you need, you can place it. Okay, so see here, this is this sample clear? You want me to repeat, am I right?
Yeah. Can you repeat again?
Okay, see, very simple. I am receiving a data from the source team for the day 0 load. Yes, I have loaded all the record, and while loading it into the target table, I can't hold the same fields just to maintain a history. When you are maintaining a history, you should be able to identify which is the new record and which is the old record. For example, this John, the 1001 record I received on last month 28th, and then later this month 1st, and then this month 3rd I got, this month 15th I'll be receiving. So there are some, in a month there are 4 to 5 occurrences of a new of this particular record I'm receiving from the source file. In case of type 1, even after the 5th occurrence of this record received, in case of type 1, how many record you will see in your data warehouse system when you query it? I'll repeat the question. In the last month, daily basis, my source system is sending a file. My project gone live 1 month before, and so I'm taking a sample of the last month. Assume 1001 employee ID record in the last month I received for 5 times. Okay, and each time when I receive a record, there is some change in the value. So all the 5 records are loaded into the target system, because each record has some variation, like location might have changed, the salary might have changed, something there is a change, and so there is an entry in a particular table. There are already 5 records for this employee inserted in a target table. Today, I received the same record again in this month. Assume this is May 1st load. In May 1st load, again I'm receiving 1001 employee record. And this is also having some change. When I insert this record, okay, I got inserted. This is type 2 SCD where we are going to maintain history. Now, from this data warehouse table, I'm querying select star from EMP where EMP ID equal to 1001. Now tell me how many records it should list.
1, 3, 4.
Why 4? Last month already 5 occurrences I received. Means I inserted those 5 records. And today is the 6th occurrence. So 6th record is also inserted. Each time when a record received, it has got some change in a value. So all 6 records should be there. And when I query select star from EMP where employee ID equal to 1001, it should list all the 6 records. Then only you will say that you are maintaining history.
History. Okay, history of a data.
Okay. So now in this 6 records, I'm asking you which is the latest record and which are the old record. How will you identify that? There should be some identification point where to tell or to differentiate these are the old records and this is the latest record which you received today. That identification can be made by using an additional column like a current flag column or data insert data when the data got inserted, when the data got updated. Most probably a flag column is used, with indicator of Y or N or 0 or 1. So what happens is when a new record is inserted, the flag will have an entry of Y. This logic we will write. If a new record is coming, it should be Y. If this record already exists, okay, yesterday this record I already inserted and today I received the same record. In that case, you need to compare first whether this record already exists. If yes, if it already exists, then today's record what you're going to insert, right? Before inserting that record, you will go back to the previous record of this employee ID, change that flag column Y to N to indicate N means it is a older record. And today's record, when you are inserting, it will go with a Y. Okay, so you will keep updating the current flag for the previous record, and the new record will be loaded with Y as a flag. So you will have a combination of N and Y in this column. If you are filtering out the records with the column value as Y for the flag field, it means it shows only the latest record. Okay, so don't confuse a lot. I know you are pretty new to all this, so you cannot imagine a lot more. But when you are moving further into the topic, you can understand. So time being, you know what is type 1. Type 2 also, you know, it is just to maintain a history. But what you're going to maintain a history, every day that load will come. Every day we used to load the data. But when we are loading the data, whatever occurrences, how many occurrences of that particular record comes in, we need to hold all the occurrence of the records, should get inserted into the data. Update or delete is not recommended in order to maintain history. So in case of type 2, you will not do insert, you will not do update operation, or you will not do delete operation. Rather, you will perform only insert operation. Is it clear?
Yeah, got it, Rekha.
Now see, this is one sample we have seen for day 0. Assume in day 1, I am receiving the same employee with another location as his office and another effective date. Okay, so this employee started working in Hyderabad location from this date till which date? Till this date minus 1. Before to this date, he was working in Hyderabad, and from this date he will be in NYC office. Okay, so in the second load in data warehousing table, I found out that this record already exists. This 1001 already exists. So what is my first step? You go to the warehouse table where there is 1001, mark the current flag to N, update it. You need to update Y to N. After updating it, try to insert this new record into the target system where office is NYC, from date is this date, and to date is previous to this date. This is business logic. Based on the project, it will vary. This is just a sample I'm showing. And since this is a new record we are trying to insert, here the flag will be Y.
Okay.
And now, assume I have one more. After a month, after some few years of data or few months, I'm receiving one more occurrence of 1001 and is location changing to California. So now what we need to do immediately, this record comes in. Every time when you are trying to load a data, you need to cross compare your current data with the previous load of data. Previous load is nothing but the whole table load. So this table now has 2 records. I will cross check this 100, the one already exists. I could see yes, it's already there. So immediately if it is already there, what we need to do, you should go and update the flag column of this particular employee. How many times it is there doesn't matter. Change all the occurrences to N because those are old records. And now the new record came in, you are going to insert. When you are inserting, you are making the flag to Y. Placing office as California, date, this date, to date is prior to this date. Now, if you query this table with 1001, you can see all the 3 records as a result, and out of 3, 1 will be Y to indicate that it is a new record, and other fields are N to indicate those are old records.
Okay.
You have complete history of this particular employee, or whatever data you receive, you will have an history. Clear?
Yeah. What is that SCD?
Slowly changing dimension.
Slowly changing. Okay.
This is a topic that we are seeing, slowly changing. The dimensions keep changing slowly. This is what the meaning. So why when it changes day-to-day load, whenever that particular record is getting a change, then you will receive a change. So that's a banking domain. I used to receive the data for every customer transaction. Today the customer ID 1001 is balances 80,000. You withdraw some amount next day, and then you are receiving a load. The same customer current balance change it to 60,000. So there is a change every day. You used to receive the change, and all the changes whatever happening or whatever you are receiving need to be maintained in your warehouse system by using a SCD type, and type 2 is a process to maintain history. Type 1 is what? Type 1
Is
what is the type?
present data.
Correct. Type 1 will have only the current data, will not maintain the history. If suppose record received with a customer having a balance of 60,000, go ahead, this balance is 60,000. Tomorrow I am receiving the same file with 50,000, go ahead and update that record to 50,000. Okay. When at the moment when you do a select star from a customer where customer ID equal to so and so, it will receive only one record because we keep updating the values on the same record. But in type 2, we keep inserting the record, maintaining a history and the current record. So there is no point of having only no point to do update or delete operation here. Rather, we do only insert. Yeah.
Yeah.
Type 3 SCD. Okay, type 3. Type 3 is a process of maintaining this data partial history. Partial history means only few, one level above history can be maintained. I'll show the sample. Day 0, same employee details received in the data warehousing table. Whatever data I received, I'm just loaded over here. Previous office and current office. This project, I know that the office field is having a lot of changes. They keep changing their office. So previous office and current office, a new field I added. So who's going to add these columns or to design this table? It's a data modeler based on the project requirement. What is our activity? We just need to load the data however we want to maintain the data. Okay. So now in course, the incremental load is coming. So here there is a second day load, Hyderabad location. Change it to the office NYC. The previous organization is in Hyderabad and now is in NYC. Its location, see, previous and current. Okay. Again, the third day, the data, not the third day, some third time the same employee has got some change in his office, and so his record I'm receiving. And now the location is California. When you are inserting same record, previous office is NYC and the current office is California. Where is Hyderabad then? Very first detail we lost. So it's just current and one level previous. Current data and the immediate previous data you can able to maintain, but you can't maintain the whole history here. Type 3 SCD is to maintain partial history. This type of maintaining the data is used in very rarely in real time. mostly in real time will go with type 2 SCD. Some cases it is type 1, but that is also very rare.
Okay.
Which SCD type your project used? Your answer should be type 2. What is type 2? It will maintain history of data. How will you maintain history of data? You need to compare today's data with previous data and first understand whether this data already exists in previous load. If yes, change that previous data load into to mark it as a previous data, and the current data you need to mark it as with the flag Y or whatever. It is not always Y, it is not always with the flag, it can be anything. For example, instead of a flag column, you can use a date column. Date will always have date, hours, minutes, seconds, and microsecond. Within a microsecond, you may not have the same record getting in. So it's an everyday load. So what happens? Yesterday timing will vary, and the next load timing will vary. So with the latest time also, you can understand that, okay, this is the latest record and these are the old records. Right, the time and date will keep changing, and it is going to increase all the time. So with the latest time, time and date, you can able to say this is what the latest record and these are all the old records.
Yeah, got it.
We have another type called type 4, which is a hybrid mode, but this is also not that used in all the projects. So hybrid mode is I used to receive data same. So when I keep adding the record for a on daily basis for the same customer or an employee, the current data, the present data, whatever I receive, I'll hold it in a separate table, current data table, and all the other previous records of that particular customer or employee or the record occurrence will be loaded into the separate table called SCD. Same fields, but you will have the previous records are loaded into one table and the current record alone will be loaded into one table. So whenever you wanted to cross check the current data, you go and check on this table alone. You will not see this table. If you want to check the history of data, you go ahead and check this history table and not on this table. So a two different table itself maintained to check the data.
Okay. Got it.
Okay, so these are slowly changing dimension. Okay, OLTP, OLAP, and star schema, snowflake schema. This is slowly changing dimensions. These are definite questions on data warehousing concepts in case of interview.
Okay.
Need to brush up all those.
Okay, sure.
Okay. We have some different types of dimensions, and one of this type is junk dimension. Generally, what is a dimension?
Dimension
what is a dimension?
is a collection of reference or a descriptive information about a measurable event.
Yes. So dimensions will have multiple attributes. Those are used to analyze the measurable event. Which is measurable event?
Fact is a measurable event.
Good. I think you are started to getting into the topic.
Yeah.
I can see that.
I'm going through it daily a little bit.
Yeah, you have to. So you understand, right? Now after our session, you are going through it, and you, if at all you have any queries, note it down and ask me in the session.
Yeah, sure, Rekha. Sure.
So now junk dimension. So what is a fact table contain?
A fact table contains numerical values and which cannot be a text value.
Yeah, that is the fact. Yeah, I understand your point. Fact table, how the fact table and dimension tables are interrelated?
Oh, foreign key. A fact table is having a foreign key.
And the primary key will be there in a dimension table.
Yeah.
Okay, now I'll put an interesting interview question here. You have different fact tables and dimension tables in the project. I am receiving data from different data sources on daily basis. Which table will get loaded first, whether it's a fact table or a dimension table?
Dimension table,
Why?
because it is having a primary key, right?
Very good. Very good. This is what the answer. But why? Why? If it has a primary key, why it needs to be loaded first?
Because it is having a reference and descriptive information.
Since it's having a primary key, a record should get inserted first on a table which holds a primary key, and then only we can have a child table insertion. In a child
Oh.
table, you cannot directly insert the record if it doesn't exist in a parent. Your answer is right. Yes, it is always a dimension table that we need to load first and then followed by the fact table. So now you see the screen here. I just kept the fact table. I didn't keep all the dimension table. I do have multiple IDs. All these IDs will have its respective dimension table because these are all foreign keys followed by the fact, amount and quantity I have. Transactional dimension table, product dimension table, employee dimension table, all these are surrounded by, for example. Okay. And all these IDs are foreign key here, so its respective primary key exists in the dimension table. Now I am having some 1, 2, 3, 4, 5, 6, 7, 8 to 9 dimension tables for this fact table. Okay. And out of all these, there are keys like payment ID, location ID, coupon ID. Okay, this dimension table just hold low cardinality value. That means only this many record will be there in that particular table, which I can understand. For example, coupon ID. This is a retail domain. When you are purchasing a product, you may use coupon or you may not use coupon to avail some offers. Okay, so the possibility in the dimension table for the column coupon ID yes or no is either yes or no, and you will not have any other answer, any other record for the table. Similarly, location ID, in which mode you can go and purchase a product. Either it can be online purchase or it can be offline purchase in store. Right? Apart from online and offline, is there any other way to go and purchase a product? No, either it can be online or you go offline and purchase the product via shops in store. Okay, so now payment ID. I am purchasing a product. What are the ways to purchase a product? You can do online purchase by using card, or you can do in-store purchase by using a cash or card. Is there any other way to purchase a product apart from cash or card?
No.
You need to purchase something. Either you use your card or you use your cash. Not any other. So now being a data model, this is data modeler part, not yours. Being a data modeler, he will analyze the data of each and every table. When he is analyzing a table, he can identify that this table is having very less weightage because I know the possibility of values in this table is only two records. Yes or no, card or cash. Using the coupon or not using the coupon. Purchasing the product in store or purchasing the product offline. Online. There is the possible of values. See, there's a gender column. You know the possible of values. What are the possible values in the gender column?
Male or female.
Male or female or even others. Not more than that. So there is something which you can able to predict. This is what it will be, and it cannot be moved. So those sort of most probably the flag column or the columns which has very minimal value, those tables are called low cardinal attributed columns. It has very less weightage. In case of customer table or in case of employee table, in case of product table, you have n number of things. You don't know to limit the number of records because it keeps growing, it keeps changing. Whereas this, it is not going to grow, it is not going to change. Those are static kind of a value. This is what the possible value. Okay, so only two record will be there in this table. Another two record in this table. You can see there is ID, pay mode of payment, card or cash. ID just to identify a record, one record and two. This is an ID. Coupon used, yes or no. Purchase in store or online. There is no third record. I cannot bring the third record because I know only two record exist in the table. That is a possible value for that particular table. N number of tables in your system will increase. More number of tables will increase more complexity because you need to join all the table. You need to provide relationship with all the table. It will be a headache if you have huge volume of tables.
Yeah.
So as a good practice, a data modeler will try to reduce the number of tables inside the scheme. So if he or she want to reduce the table, first point they will understand is what are the possible value table exist. Now in this sample, I have three possible value tables, that is three low cardinality table. Instead of having these three dimension tables separately and giving a primary key here and having a linkage here to foreign key, I'm just thinking, can I do something better to avoid these three tables into a single table so that my number of table will be reduced and the integrity will be simple, all those samples. Okay, so now see the data sample here, transaction ID, product ID, employee ID, customer, all these data. I just put it here. I'm having some data sample here. So how many IDs? Payment ID, location ID, coupon ID I'm holding. Payment ID 1. If you want to understand what is payment ID 1, you need to check for this payment dimension table. 1 is card. Location ID 1. You will join location dimension table and say 1 is in store. Similarly, coupon ID, you need to join this table and bring 1 is yes, coupon used. If it is 2, coupon not used. So to bring this table, to understand this IDs, you need to combine all this table. And so instead, what we can do is, forget about this, we will create a new table. Okay, mode of payment, purchase, location and coupon used. Will write down all the combination. If the mode of payment is card, what are the ways that you can do the purchase? Either you can go in store or you can go online. And if it is going in store, either you can use coupon or you may not use coupon. Similarly, if it is online also, coupon yes or coupon no. So we know the possible value. You will see the possible all combinations of the data over here. And another possible value for cash. For cash, always it is in store. In online, you cannot do the cash purchase. So this will be ruled out. This is just to show a negative sample I entered here. With cash, you cannot do online.
Yeah.
You can do online purchase only via in-store. So mode is in-store, but in in-store, yes, possibility of using a coupon, yes or no is possible. Okay, so I have this set of records, combined all the possible value table and put it in one table. And to uniquely identify the record, yes, I will have the surrogate key generated here. 1, 2, 3, 4 sequence number. What is surrogate key? So there comes into another topic in RDBMS. Primary key is something used to uniquely identify a record on the column, on the business column, the data on the customer ID or the student ID, the ID columns that you are going to insert. Because with that data, you can easily identify a record. Now, from business, I don't have a column to provide a uniqueness. Instead, I myself create a column, and for that column, I will assign a sequence of numbers. 1, 2, 3. So it's a unique number with which you can able to identify a record. Okay. So surrogate key is introduced by ourselves whenever you wanted to introduce or uniquely identify a record. And this is artificially added column to uniquely identify a record by holding a sequence of numbers. It's always a number, it's a sequence of numbers. Okay, when to bring the surrogate key? When you want to identify a column with the business data, and on the business data, I don't have privilege to say, yes, it is a duplicate. See, now the selected column is a business data. With the card, I cannot identify because I have repeated card. With cash, I cannot. With purchase in store online, with this open code, I have duplication. With this, I cannot uniquely identify a record. I don't have any other new column to uniquely identify a record. So I am introducing myself a new column and making it as a surrogate key where I'm generating a sequence of number to it. Now I can able to easily uniquely identify each of its records. Getting?
Yeah.
But if you see here, for example, I have a employee ID, employee name, all these are the data from business. By using employee ID column, I'm making it as a primary key where I can uniquely identify a record. So on the business data, if you can able to uniquely identify a record, put that column as a primary key and make each record is identifiable. If your source, if your business data is not allowing you to have a uniqueness, then we manually put a column as a surrogate key and bring the uniqueness by having a sequence of numbers.
Okay.
Here, the difference between primary key and a surrogate.
Okay.
Now I have this. We are coming back to this topic. Uniquely, I have a all combination of this data, and I have this. Now in this table, now from this transaction table, all the same, the transaction ID, product ID, employee ID, everything. Junk ID, I am making one column, dimension 1, 2, 3, and something. Wherever there is one, what I can do is I can move on. One means it's a card, in store, and Y. So instead of having 3 different dimension table, I'm trying to keep only one dimension table that gets linked to the fact table. I'm trying to reduce the dimension table. So here instead of having these 3 low cardinality table, for low cardinalities, why do I need to have multiple dimensions? Rather, I will keep it with the one dimension table. I'll try to combine all the data into the same table, and that type of a table is called junk dimension. So what is junk dimension? The dimension which has low cardinality, all those dimensions are grouped together and put in a one table called junk dimension, and to uniquely identify, we hold a sequence number in it, which is a surrogate key. Getting? So if in a schema where there is a low cardinality dimension, make everything into a possible value table and make it as a single table. All the junk values, put it in one table called one dimension table. Then junk dimension. I hope it's clear. If not, go through it and ask me one more time.
Yeah.
Next type of dimension is confirmed dimension. Okay. Now, a fact table will be referenced by multiple dimension tables. Assume in a target data warehouse, I have 2 different schemas, star schemas, and one each referencing a different fact table and different dimension table. Another schema also having a different fact table and different dimension tables. But the dimension tables of these schemas at some point, either 1 or 2 dimension table will be common for both the schemas. See the screen here, I have a sales fact table, I have inventory fact table. For inventory, there are some 5 dimension tables: time, product, staff, inventory, vendor. And for the sales fact table, there are some 6 dimensions: purchase, branches, location, sales area, staff, product, and time. In the same database, even though I have different schema, for these 2 dimensions, there are common dimension that exist. Example, you take a time dimension. For any fact, if you want to analyze yearly, quarterly, monthly, hourly, this time dimension will have only these values, these attributes. So this time dimension may be a common dimension for more than one facts. I have multiple facts in my table, multiple facts in my database, and those facts are analyzed via the time dimension, date dimension. I have fact 1, I have fact 2. These two facts are in different schemas. Okay, what is a schema? Assume what is a star schema? Centrally located fact surrounded by multiple dimensions. Now, fact 1 is having its own respective dimension. Fact 2 is having its own respective dimension. In fact 1 also I have a time dimension. In fact 2 also I have a time dimension. And time dimension attributes are always same: yearly, monthly, weekly, quarterly, hourly. Okay, you are going to analyze these facts with the time factor. Now, for those two facts in the different schemas, the common dimension is time. So instead of having time dimension table twice, I will have only one time a time dimension. And I will have linkage from this fact table. Also, I have a linkage from another fact table. So the dimension which is common for multiple facts or nothing but a confirmed dimension. See the figure here. This time dimension is common for the sales fact. Also, it is common for the inventory fact.
Okay.
The dimension that exists as a common for both the or for more than one fact is nothing but confirmed dimension.
Oh, okay.
Got it?
Yeah, got it.
That is confirmed dimension. So, jump dimension, confirmed dimension, and slowly changing dimensions. The topic that we have seen. Clear? Just go through it like what you are doing. I'll even brush up for next session.
Okay, Rekha. And about that, I forgot. Resume. Yeah.
I didn't get a chance to look into the project. If you have any other project, you got any of the samples, project samples?
Even I did not. Today I will go and search for it.
Yeah, go through it. Even I'll also go through it today. Try to make it by tomorrow.
Okay, then. Okay. Yeah.
I'll stop here because I know the content for you to go through is more for today because it has got multiple variations. Go through it. And see, when you Google a topic or when you are searching for something, you will have n number of things resulted. So take the relevant, don't take more irrelevant content into the topic. It will actually mislead you. So whatever I'm saying is more than enough. Just with the same keyword, you go through.
Okay, Rekha. Okay, Rekha. Then. Okay. Yeah.
Thank you so much.
Bye. Have a good day. Bye, Rekha.
Thank you. Good night.